So in 71, you're given some time with the corresponding velocity of a rocket that's leaving Cape Canaveral. So if you plot those points, you would get a graph similar to what I have over here. You will notice that for the most part, it ends up being very straight. So essentially it starts off at 0, 0 here, goes up to here. You can see that a few of the points are above, a few of the points are below. It's a slight curve, but for all practical purposes, we can model this with a straight line. So in the next part, we're asked to go ahead and basically find an equation of a line that models this very closely. Now, you could either use your calculator to do it. If you've had stats, you should know how to do that. Or you can use StatKey if you've had stats. If you've not had stats, just go ahead and take this answer as it is. We'll say our output, our velocity, is equal to 23.5 times t, which is our input. You could approximate that also looking at your graph, knowing it starts at 0, 0, ends up at approximately this point, do a change in y over change in x, and it gives you about 23.5. If you wanted, you could actually use words that velocity is equal to 23.5 times whatever your input time is. So in part C, you're asked to approximate the altitude of our rocket. Altitude is distance. Where does distance show up on this graph up here? Well, for all practical purposes, for looking at the idea of units, suppose I gave you this rectangle here. That would be 200 feet per second, and then this would be 20 seconds. If you try to look at the area of that rectangle, it would be 200 feet per second multiplied by 20 seconds. And you can see that your seconds would drop, leaving you with feet. So your area underneath this curve represents our feet, which is our distance, which is what we are looking for. So we're looking for the area, and in this case, our area happens to be a triangle. And so to find the area of a triangle, you know that that's 1/2 base times height. So our area is 1/2. Our base, we're asked to go for the first 40.32 seconds. So we'd be over here at 40.32 for your base of how wide the triangle is. And then your height is how far up you would be. Well, at 40.32 seconds, you can see that you're up at, oh, I looked at the wrong one, 40.32, you're up at a height of 965 feet per second. And you can see that the seconds, once again, would drop. You multiply that out, and you would get 19,454.4 feet. In D down here, you're asked to go ahead and find the velocity. Well, this is a velocity graph, but you're asked to find a velocity at 10 kilometers and 50 kilometers. Well, up here, when we are looking at our units, our area is representing our distance, like kilometers, but it's in the units of feet that we had shown. So first of all, you have to go ahead and convert each one of these to the correct units of feet. You can go ahead and type 10 kilometers equals and put feet into Google, and it will give you this, or you could use dimensional analysis and work that out. And then similarly for your 50 kilometers. We know that our area, our distance, is representing our area, which is our triangle. So we can take our distance and plug that in, equal to 1/2. Now we don't know how far over we have to go. If you don't know how far over you have to go, that means that your variable, in this case I'm going to say it's my time, because time's my horizontal axis, and then I got to have my height. But according to my equation right here, whatever my time is to find the height of this triangle, which is my velocity, all I have to do is take what I plug in and multiply it by 23 and a half. So my height is 23.5 t. Notice on the right side we get a t times a t, which is a t squared, and then half of your 23 and a half is 11 and 3/4. So then you can divide both sides by 11 and 3/4 and then take your square root. That gives you your time. Gives you your time to get to your 10 kilometers high. You're asked to find velocity. Well, we know velocity is 23 and a half times your time, so all we have to do is plug in our time that we just figured out of 52.4 or 84, and then we can multiply it together, and then we would get this with our units. Essentially, for the next part, you just have to repeat that, except instead of starting out with 32,000 feet, you're starting out with 164,000 feet. And then you repeat that, working out the right-hand side, dividing, taking your square root, taking your time, plugging it in, and then you get your velocity to be this.